Accessing object memory address. When you call the object._repr_ method in Python, you get something like this back. Is there any way to get a hold of the memory address if you overload _repr_ other than calling superclass obj._repr_ and regexing it out?
The Python manual has this to say about ID. Return the identity of an object. This is an integer, or long integer, which is guaranteed to be unique and constant for this object during its lifetime. Two objects with non-overlapping lifetimes may have the same ID value. Implementation note: this is the address of the object. So in Python, this will be the address of the object. No such guarantee for any other Python interpreter, though. Note that if you're writing a C extension, you have full access to the internals of the Python interpreter, including access to the addresses of objects directly.
You could re-implement the default repr this way.
Just use
There are a few issues here that aren't covered by any of the other answers. First, ID only returns the identity of an object. This is an integer, or long integer, which is guaranteed to be unique and constant for this object during its lifetime. Two objects with non-overlapping lifetimes may have the same ID value. In Python, this happens to be the pointer to the PyObject that represents the object in the interpreter, which is the same thing that object._repr_ displays. But this is just an implementation detail of Python, not something that's true of Python in general. Python doesn't deal in pointers, it deals in Java references, which the JVM of course probably represents as pointers, but you can't see those, and wouldn't want to, because the GC is allowed to move them around. PyPy-lets different types have different kinds of ID, but the most general is just an index into a table of objects you've called ID on, which is obviously not going to be a pointer. I'm not sure about IronPython, but I'd suspect it's more like Python than like Python in this regard. So, in most Python implementations, there's no way to get whatever showed up in that repr, and no use if you did. But what if you only care about Python? That's a pretty common case, after all. Well, first, you may notice that ID is an integer. If you want that 0 by 2 ABA1C0CF890 string instead of the number 46,978,822,895,760, you're going to have to format it yourself. Under the covers, I believe object._repr_ is ultimately using print%p format, which you don't have from Python. But you can always do this. In 3.x, it's an int. In 2.x, it's an int if that's big enough to hold a pointer, which may not be because of signed number issues on some platforms, and a long otherwise. Is there anything you can do with these pointers besides print them out? Sure, again, assuming you only care about Python. All of the C API functions take a pointer to a PyObject or a related type. For those related types, you can just call pyfoo_check to make sure it really is a foo object, then cast with pyfoo_p. So, if you're writing a C extension, the ID is exactly what you need. What if you're writing pure Python code? You can call the exact same functions with Python AP from C types. Finally, a few of the other answers have brought up C-types.addressive. That isn't relevant here. This only works for C-types objects like C_int32, and maybe a few memory buffer-like objects, like those provided by NumPy. And, even there, it isn't giving you the address of the C_int32 value, it's giving you the address of the C-level int32 that the C_int32 wraps up. That being said, more often than not, if you really think you need the address of something, you didn't want a native Python object in the first place, you wanted a C-types object.
If you want to see more, please consider subscribing.